Right. So the chemical reactions. Based on the heat change, we are dividing into two. We name it as exothermic reactions and endothermic reactions. Exothermic reactions and endothermic reactions. Did anyone learn this lesson already? Have you learned? What is exothermic and endothermic? Very simple process. Right? Now I say, during a reaction, heat may be increased or decreased. Temperature may be increased or decreased. Now, what is the difference between heat and temperature? Right? You should have an idea about that. Because some people, they think that both of them are same. Temperature is a measure, okay, of average kinetic energy of the particles. All the materials are made up of particles, right? Maybe solid particles, liquid particles, gaseous particles are there. So the particles, when you're concerned, what is the average kinetic measure? Kinetic energy means. Now the particles vibrate. When you are taking a solid particle being at one point, fixed point, it vibrates. Around that point, it vibrates. It never moves from one point to another. So that when you are taking a solid, it is at one particular place. Right? The particles are not moving here and there. If it is happening, this may be changing. It's not happening. Right? But a liquid, when you are just spilling off, you can see it moves. It flows. This is because of those particles can move fast on one another, sliding on one another. Gases randomly move freely, fast and freely they move. Right? This is how the physical arrangement of the particles appear. Now, when you come for these particles, since they are vibrating, so anyhow, all three are vibrating, right? So this vibration is a sort of motion. It might not be moving from one point to another when you come for solid, but yet it is a sort of movement, vibrating. So due to this motion, due to these vibrations, they obtain an energy. Moving objects contain an energy called kinetic energy. So this is how kinetic energy is connected here. All right. So they move. They show random motion. So due to this motion, they obtain kinetic energy. So what is the average measure of the kinetic energy? Kinetic energy obtained by the particles in a matter. Inside a matter, whatever the particles are there, what is the kinetic energy obtained by them? That is what is termed as temperature. So when you increase the kinetic energy of the particles, temperature should be increasing. Or on the other side, if you increase the temperature, kinetic energy increases, which is in direct proportion. All right. And now, if a substance is having a high temperature, it is supposed to be having high kinetic energy, right? And another substance object is there. Okay, let's say the first object is A, second object is B. It's relatively at a lower temperature. That means lower kinetic energy. Now, A and B both, when you are taking closer contact on one another, A is high tempered, B is low tempered. Now, from high tempered object to the low tempered object, which is possessing high energy and low energy. By high tempered means high kinetic energy, low tempered object is lower kinetic energy. Now, from high kinetic energy to lower kinetic energy, usually energy flows. So, energy transfers. So, now what is the energy being transferred from high temperature to lower temperature? This energy is what we term as heat energy. This is the energy called heat energy. So, heat transfers from high temperature object to lower temperature object. Clear about that? So, when you come for this part, here too, there is a sort of change happening due to this because of the temperature change. Heat also change. Now, during the reaction, we already learned how reactants are being converted into products. Exothermic reactions means these are the reactions where heat is released. That means During the process, heat will be released out. What is the heat it obtains? From that, a certain amount of heat will be released out. Certain amount of heat will be released out. But endothermic means opposite of that. Heat is absorbed from the surroundings. So now the heat is released to the surrounding. Here the heat is absorbed from the surrounding. So these are the two types of reactions. And during this change, what are the interconnected stuffs happening? Now heat is released and it is something like this. Reactants are what being converted into product. Aren't we understanding? Reactants are what converted into product. Now I'm the reactant, let's say. I'm the reactant. I have imagine 1000 joules. Example, I have got 1000 joules. So now I gonna become the product. I'm converting into product. Now when I'm converting into product, according to exothermic, what I should do? Heat should be released. I'm releasing out about 200 joules heat. I'm releasing about 200 joules heat. I got 1000 joules. I become the product releasing 200 joules. Now, am I having a lower energy or a upper energy? No, lower energy, right? Why? Earlier I got 1000 joules. Now I become the product releasing heat. Releasing heat. So product plus heat. I got only 800 and 200 heat. So this process is what happening during exothermic reaction. Accordingly, during this process, what happens? The heat, if you're gonna take heat of the reactant and heat of the product when you are comparing, whose heat will be more here? Reactant's heat will be more. I got 1000 joules, releasing 200, I become product with only 800. So product should be less. Is that clear? Clear about that? What's happening in endotherm? The reactants, I'm the reactant, input. I'm gonna absorb heat. I got only 800 joules and I'm going to absorb heat about 200. So 800 plus 200, I become the product of 1000 joules. 1000 joules. So at this case, what's happening for me? My heat is, the joules I obtain, the energy is increasing. So accordingly, when you're gonna take the heat of reactants and heat of products, whose heat should be more here? Products heat should be more. Products heat should be more. Clear about that? So reactants heat is more in exothermic, products heat is more in endothermic. So now from this we're gonna calculate the heat change. Delta H. Delta H means heat change. Heat change. Okay. Or we say enthalpy. The word enthalpy we are not using in national curriculum, but yet it may be asked in some questions. So enthalpy means that is the heat change. Heat change. Okay. Let me write some keynotes here. Heat is H I'm writing here. R is the reactant. P products. Delta H means heat change. Or another word, enthalpy. Right? So now, how am I supposed to find out the delta heat change? Always we find it out from 2 minus 1, right? Second minus first. 2 minus 1. Who is the second one? Product is the second one. Reactant is the start. So what I do, I'm going to take it as heat of product minus heat of reactant. Not only here, even here the same thing. Delta H is equal to heat of the product minus heat of reactants. But we don't have any numerical values, right? So if you ask me again, why product first, why can't we take reactant first? Because if we want to take the difference from the secondary, you have to reduce the primary. From the second instance, first instance, you have to reduce. Then only you can find out what is the difference taken place. Okay. So accordingly, product minus reactant, but we don't have a numerical value. But can you see here? When you're gonna take this, product is a plus value, reactant is also plus value here. Okay. But when you come for this equation, product is plus, reactant is minus, right? Product is plus, reactant is minus. And who is more here? Reactant is more. So it's something like plus 5 minus 8. Plus 5 minus 8. How much should be the answer? Minus 3. That means the answer should be a negative value. Got it? So exothermic reactions are negative value. They give negative value. Is that clear? The heat change of exothermic reactions are giving negative value. Negative value. So the same way when you're gonna take this here. Difference you are taking. Who is the highest value? Product is the highest value. If the product is highest and product is first means definitely it should be giving you a positive value. Correct? Correct? Because product is highest fixed and the difference when you are taking product should be plus, so the difference should be a plus value. So accordingly, you see exothermic reactions are giving a heat change with negative value, while endothermic reactions are giving the heat change with positive value. Clear about that totally? Alright. So what's happening here actually? The heat change, the heat release means. It is something like this. Now let me take, this is the reaction. This is a reaction. And this is the surrounding system. Okay. This is the process where the reaction is happening. It has got a certain temperature initial. It has got a certain temperature initial. What it does, it also it is having a heat. During the reaction, heat is released, like heat is released. So the heat is released to the surrounding temperature. Heat is released to the surrounding temperature. Is that clear? When the heat is released out, okay, heat is released out, I'm releasing out the heat, my temperature reduces. But the surrounding temperature increases, right? So we concern the surrounding temperature here. So here, since the heat is released, the heat is released. So because of this, outer temperature increases. Outer temperature increases. Understand? And this is why during exothermic reaction, the temperature increases. Temperature increases. That means in a reaction, initially I'm starting off with a certain thermometer. Initial temperature is 30, let's say. After some time, it gives you 45. That means temperature has increased. Then what type of reaction should be? Exothermic. Heat is released out, so the temperature is increased. Temperature is increased. But reactant's temperature reduces. As a compiled, mixture, the mixture's temperature increases because of the heat is released out. So the same thing when you're gonna take here. The surrounding. From the surrounding to the reaction. This is the process where the reaction is happening. From the surrounding to the reaction, heat is absorbed. Heat is absorbed. So when the heat is absorbed from the surrounding environment, the surrounding process, okay, my temperature increases, but surrounding my system where the reaction is happening, here the temperature decreases. Correct? Correct. So this is why the temperature is reduced during endothermic reactions. Endothermic reaction. So the same way, let's say 50 degrees Celsius you are starting up with. After the reaction is completed, it becomes about 35. So the temperature has reduced. Why? Heat is absorbed during the process. So what type of reaction it is? Endothermic. Endothermic. Did you understand? Okay. So related to them, there are some energy level diagrams also we are supposed to do. So those energy level diagrams are also very easy with the list. Okay. Any questions here? Any parts not clear yet? Yeah. So when we are comparing these reactions biologically or chemically, can you remember two words you learned? Anabolism and catabolism. Anabolism means building up reactions. Catabolism means breaking down. So tell me, is it during anabolism or catabolism you have to provide energy? Is it to build up something or break down something you have to give energy? Build up. To build up something you have to provide energy. Otherwise you can't build it up. Spending energy, right? Spending energy, absorbing energy, you have to build up something. You have to build up something. So anabolism, anabolic activities provided with energy or else absorb energy, consume energy to build it up. So anabolic reactions are what gives you endothermic reactions when you are comparing with heat change. And catabolism is breakdown, right? During breakdown, the absorbed energy will be released out. Okay. So absorbed energy would be released out during breakdown. So releasing out means exothermic. Exothermic. Furthermore, some examples. Photosynthesis. Is photosynthesis a building up or breaking down? Photosynthesis. Carbon dioxide plus water combines together gives you glucose. So is it a building up or breaking down? Building up. It builds up. It builds up, right? So it is a building up reaction. So during this, what is the energy provided? Sunlight energy is absorbed. We are writing sunlight as a feature factor in it, right? So sunlight is obtained. So absorbing energy it is done. So it is endothermic. Endothermic. Opposite of photosynthesis, cellular respiration. That also you learn, right? cellular respiration when you are taking, it is breaking down glucose into carbon dioxide and water, releasing energy. Releasing energy. So releasing energy means what type of reaction should be? Exothermic reaction. You understand? So this is how we are going to be. Clear? So exothermic, how do you remember? Exothermic, release energy, minus value. These are the three key points. Exothermic, release energy, minus energy, minus value. Or else another word you can add up here, 4 points. Exothermic, release energy, reactants more, minus value. What are the four? Repeat up things. Exothermic, release energy, reactants more, minus value. Exothermic, release energy, reactants more, minus value. Endothermic, absorb energy, products more, plus value, positive value. So endothermic, absorb energy, products more, positive value. Okay, negative value, positive value. So these are the four key points you have to remember to compare. Totally clear? Clear about that now? Right? So during exothermic, temperature increases, during endothermic, temperature decreases. We'll make a note on a writing book. Take separately on one page, because even after this, we have to draw energy level diagrams. Then if people have it done. Completed, right? Right. So the energy level down. Very simple to do. There are two ways. Okay. Both the ways may be there, but fundamentally what is given in our syllabus is this. Just three lines. Whenever the question asks you to draw, first line a vertical line, and there should be two horizontal lines. Here we get the energy. Usually energy is measured in kilojoules per mole. It's because of this energy should be taken for a mole in kilojoules it gives, right? Or else sometimes it will be given in joules per mole. That depends on the question. What is the unit they give that we have to mark. So here, usually when you come for a vertical axis, when you go up, value should be increasing, right? Correct. Right. And on the horizontal axis, we are going to name if it is the reactant or product. Exothermic reaction, we are coming, O is more in reactant, product is less. Then O should be there at the higher value, reactant, right? So I'm writing the reactant. Reactants becomes the product. So the product is less. Reactant more, product less. Okay. And when we are writing, this is the general term I am giving, we have to write the chemical equations. And in chemical equations, we have to make sure we are writing the solid, liquid, gaseous states as well. Now, always the reaction happens from reactant to product. So, reactant is there at the upper level, product is relatively lower. What I do, I'm marking this down, the arrow. That is to denote that reactant to product, the reaction. And during this reaction, what is happening? Heat is released out. So, we are showing it like arrowhead out. Arrowhead shows you out. Heat is released. Sometimes in the question they will give the value. Let's say minus 200 joules per mole. What you have to do? Heat is released minus 200 joules per mole. You have to write. Or else heat is released is not essential there in that case. Minus 200 joules per mole you can write it to show that that is the amount of heat released out. Okay. So very simple, very simple. And the next one again, three lines. Now you know how to do it. Here the energy we mark, it may be kilojoules or joules per mole. Who is greater here? Product is greater. So I'm writing the products here. And the reactant is less. So this is the reactant. Reaction always takes place from reactant to product. Reactant to product. So the arrowhead should be shown upward. Right? And the arrowhead should not be exceeding more than this level. It should be within that. And during this reaction, what is happening? The heat is absorbed. Earlier heat was released, now the heat is absorbed. So what are we showing here? We are showing the heat is absorbed. Or else, if it is a positive value given in the question, we have to write the positive value. Clear? Is it hard? Very easy. This is a general term. When you come for the equation, they will give the equation A plus B becomes C, something like that. They will give that equation. You have what equation gives you the reactant part should be written at this place in exothermic and product C. And if it is endothermic, reactants here, product. But with the solid, liquid, gaseous state. What are the physical state? You have to write. And it should be a balanced equation as well. Both sides should be balanced. So these are the conditions you have to follow. Clear about that? Okay, let's note that down. But you have to use the rulers when you are drawing. And the line should not be crossing out. I mean, should not be extended. Because these are the lines it is starting up. And this is one type of diagram. Another type of diagram is also there. I can first draw this. Better just below the diagram, but you have written already, just below that. If you don't have space, go to the next page. right? Reactants absorb the heat and become the product. Reactant release the heat and become the product. Anyhow, the input is reactant. Starting is reactant, ending is product. Product is what produced, right? Reactant is spent. Okay, always reactant to product. Exothermic reactant release the heat and becomes the product. Endothermic, same like reactant, absorb the heat and becomes a product. Two directions. Okay. Any questions from you people? Right. So what is the other type that we are supposed to draw this energy level down? Here the energies. Reactant is more, product is less. I'm going to start up the reactant somewhere here. Right? Reactant becomes the product upon releasing heat. So releasing heat means heat is reduced and becoming the product, right? So that the product is less, right? So product is somewhere here. Product is somewhere here. What I do, I'm going to connect that. So this becomes the reactants. They reduce the heat, release the heat, and becomes the products. And this was the starting heat, and this line, this gives you the ended up. Okay, I'm dragging this. Right. Right. So, and you can see this is the change amount, right? This is the amount change, right? Correct. From reactant to product, is it increased or decreased? Decreased. Right? Reactant to product, it is decreased. Decreased. So this is the change. So here you can write heat is released. It is released. And that is why, let's say it was 50 and this was 20, 50 to 30, it is reduced. Alright? And endothermic reaction we are taking. Energy, and this is what we are taking here is the direction of reaction. Reactant, they obtain, they got a smaller value, a less value, relatively a lower value. And they becomes the product increasing. So here the reactants were increasing, that means absorbing the heat becomes the product. So this is the level difference between them. And that is the amount, you can see it is now upward. And this is the amount heat is absorbed. Got it? So two different diagrams, but relatively the same. Same here. Draw them to. Basically, the first one is what they ask you to do. And this may be given as a question. Okay, but same. Done? Please have a quick recap. If you have a question, you may ask me. Fine. No questions, right? Right. We'll read the tune. Chemical changes are the changes in which the combustion of matter forms matter changes forming new substances. Okay, they are called chemical changes, chemical reactions. So you can see there. Look at the tune for me. Right. Right there. Look at it, tube. Topic, write the topic there inside the text box as given. Exothermic reactions, endothermic reactions. Exothermic reactions, endothermic reactions. So we are writing a definition for the exothermic part. Exothermic. The reactions the reactions which release heat, the reactions which release heat, or else we use the word liberate also. The reactions which release heat during the process or during the reaction, you can write, are called exothermic reactions. Are called exothermic reactions. Are called exothermic reactions. Right? And there we write this reactant gives you product plus heat. Better you write completely by words. Reactant gives you product, gives you means the arrowhead, products plus heat. So endothermic reactions, the reactions, the reactions that absorbs the heat, that absorbs the heat